Hello all, welcome to part 2 of the Format String Vulnerability Primer for Hacker video series. Now in the last video, we saw how it is possible to leak information from a program using a format string overflow vulnerability. Now in this video, we will take an in-depth look at why it is really possible to exploit format string vulnerabilities. So let's actually open up the previous program which we had written, format string simple.c, and let's go ahead and replace this line for the time being with a more common use of printf. Right, so a very simple modification. All we've done is now we've mentioned a format string ourselves and are just printing the argument passed by the user. So let's go ahead, compile this. Okay, and now let's run it. Let's give hi as the input, and if you notice, print this hi gets printed on the screen, right? Now this is, I guess, the very common use of format strings. Let's load this program up in GDB and look at exactly how the program is working. Now we've discussed a GDB primer in the assembly language tutorial, and also looked at how to examine the stack, etc. in the buffer overflow tutorial. So if you're not familiar with all of these concepts, I would request you to go back to those tutes and have a look at them before actually coming here and looking at this video. Okay, so having said that, let's list the file. So if you notice, this is our program. Now let's actually disassemble the main function. Right, so if you notice, this is the place where the printf is actually called, right? And what we'll do is, let's actually go ahead and set a breakpoint for this address. So just before printf is going to be called, we've set a breakpoint. Now let's run the program and give it the input hi. Okay, so we've hit our breakpoint. Now what we shall do is, let's examine the stack. Okay, and let's also print out the frame pointer. Okay, so basically, using EBP, what we know is, this is basically the frame pointer which is saved on the stack, and this is the return address from main, right, which would be libc_start_main. So we can verify that by disassembling this part. So we are into libc start main, right? Okay, let's now go back, print these once again. Okay, so if you look at ESP, we know that this is the return address from main. This is of course the stored value of the frame pointer, and these are pointers to the two secret strings, right? So we can verify that. This is secret 2, and then we can go ahead, print the next pointer which is stored on the stack. This is secret 1, right? And if you recall, in the assembly language primer, the arguments to the function printf are also now going to be stored onto the stack, right? So what is this? This is basically the argv1 input which the user has supplied. Now, if you notice, this address is much higher up in memory, right? And when the program is invoked, the arg v1, this pointer is actually set there appropriately, much higher up in memory. So what is this? This is a pointer to our format string, right? This is our format string, print this, and then we have %s/n. So, I guess you guys should be familiar with this because we've looked at exactly how the program stack is set up before a libc call is actually made, right? If not, let's actually quickly go back to our slides and recap the entire scenario. So printf is a variadic function which can have variable number of inputs, right? And those inputs are specified using the format string. So let's say there is a format string containing a description of n different data types, %s, space, %d, so on and so forth till %s. And then of course you mention those n arguments, arg1 to argn, right? Now for such an invocation, how does the program stack look like? Now once printf is called, inside printf, of course, you're going to have the return address back to the caller of printf. Then you have the format string stored, as we have seen, right? The first address here is nothing but the format string. Then you have arg1, which was high in this case, right? If you notice, the second thing on the stack is basically the first argument to printf. Now, of course, in this case, we just have one single argument which is going in. However, if we had n arguments, then arg2 to argn, pointers to them would also be stored onto the stack, right? So quick recap of this is how the program stack looks like in the case of printf. Now, what is the problem? Well, the problem really is, how does printf work? Now, printf simply looks at the format string which is passed to it. And then it says, okay, I just have one single argument, which is a pointer to a string, which I need to pick up from the stack, right? So it goes ahead happily and picks up the next 4 bytes from the stack and interprets that as the pointer to the string it needs to print, and then goes ahead and executes. So basically, the format string controls how the printf function will interpret various pointers or other variables stored on the stack. So now with this basic in mind, let's now go back, exit this program, and go ahead and go to formatstring.c and actually make one more modification, which is just add a %s. However, let's forget to add the argument and the extra argument too. Now let's recompile this program, and now let's execute it. If you notice, high got printed as well as this is a secret one got printed. Now why did this happen? Once again, let's quickly load up GDB and set a breakpoint. Just before printf is called. Let's run the program with high as input. Hit the breakpoint. Now let's look at the stack. So if you remember, just as the last time, this is going to be the pointer to the format string. Right now, the format string basically says that 2 inputs should be expected on the stack, right? However, in our program, we have only mentioned one single input, which is argv1, and that is of course the next thing stored on the stack, right? But when printf actually looks at this format string, it does not really know whether we put all the variables correctly on the stack. It just looks at this format string and says, okay, So the first thing I need to get from the stack is a pointer to a string. And basically what it gets from the stack is this value, which is nothing but a pointer to the string hi. Then it says, oh, the user has actually mentioned another pointer to a string. So let me actually pick up the next value from the stack. And this is what gets picked up. And that is why this is a secret one also gets printed, right? So if you continue the program, you will notice that both hi as well as this is a secret one both get printed. Now, of course, just by common sense, if we had mentioned a third argument, another %s, then the next value would also be printed from the stack, right? So very quickly, we can just modify our program. I'm actually going very slow just to make sure that you're following every bit of this. Let me recompile the program again and let me run it. So if you notice now, hi, which was our input, and this is a secret one and this is secret two, both have gotten printed, right? So hopefully this part is clear, how printf actually looks at the format string, decides the number of arguments and fetches them from the stack and prints accordingly. Now, of course, if you cannot delete this statement and go back to our original program, where we are now fetching the format string from the user itself. Let's recompile. Now let's run the program. So of course, when we put hi, nothing really happens. But if we put %s, immediately this is a secret gets printed. Now, I guess you guys must already have understood why this happens. Let me just load this up in GDB and make it doubly clear. So let's disassemble main once again. Set up a breakpoint. And run with an input %s. Right? So now if we were to look at the stack, the first thing, once again, if you look at the slides, is nothing but the format string. So if you were to print this, this is the format string, which is argv1, which the user supplied. Now when printf looks at this, it says, oh, I need to pick up a pointer to a string from the stack. So it picks up the next value and simply goes ahead and uses this in the printing. And that is where this is a secret one gets printed, right? Now, instead, if the input to this function was %s, then what actually happens is printf first of all fetches the argument, format string from the stack, says that 2 pointers to strings are expected. So it actually fetches the next 2 values from the stack. And as expected, these 2 values are going to be pointers to this is a secret 1 and this is a secret 2. And that is where if we continue, both this is a secret 1 as well as this is a secret 2 get fetched. So well, that's all for this video. Hope you understood why using a format string it is possible to go ahead and leak information from the program by using vulnerable functions. I hope you like this video. Would really appreciate if you can leave behind a comment. Also, if you have any additional questions, please join our forums and post your questions there, and we will try our very best to get back to you immediately. Well, that's all in this video. In the next video, we will look at how to go ahead and exploit format string vulnerabilities further. Thank you.